So now let's look at the components of JVM, and then we'll look at the Java runtime memory area. JRE stands for Java Runtime Environment. This consists of two things. That's the JVM and the Java API. The JVM consists of the following components. You have the class loader, bytecode verifier, garbage collector, security manager, and the execution engine. Now, when exactly does the JVM execute? In case of an application program, in order to run an application program, we use the Java command. That is when we create an instance of a JVM. Whereas in case of an applet, since applet runs in a browser, we come across something called as an applet tag. So when it reads an applet tag, before it can go and fetch the applet class, it loads the JVM in the browser and then brings the applet class and loads it into the browser's JVM. So once you have a JVM, it consists of these following components. What are the functionalities of each of these components? The class loader is responsible for bringing in the class file into the JVM. When it brings in the class file, the class loader is like a namespace. It's an area within which the class files are loaded. So whichever is the first class to be loaded, there's a primary class loader object. A class loader is nothing but another class. So an object of class loader is created initially, and using that class loader, it loads the classes one by one using the same class loader. So if I have a class with a main function, that's the first one to be loaded in case of a application program. So that class might be using other classes in return, and those other classes might be using some other classes in return. So all of them will be loaded by the same class loader. If I were to have two different class loader objects loading the classes, then they get loaded into two different namespaces. Classes loaded into two different namespaces cannot interact with each other. So we will have a same class loader object which has been created, which loads all the class files. You can, since class loader is a class, you can always create an object of class loader and load classes via that. That's one way of creating a separate class loader and loading classes. So once a class loader loads a class file into the JVM, remember in the class files, you will be using certain other classes coming from different packages. So you will have only that explicit path to that particular class which you have mentioned. But now the classes are loaded into the JVM into certain memory space. You need to replace those paths to the actual memory addresses. That is done by the bytecode verifier. So the bytecode verifier replaces the class paths to the actual memory addresses where the classes are loaded. The garbage collector. This is one other important feature we did not mention in the list of features, okay, which you can add into. Garbage collector is used to remove objects which go out of scope, because in Java you can create an object by giving a new keyword, but you cannot actually remove an object or delete an object once it is done. You would either say free an object or delete an object, right? Which is not allowed in Java, because see, in C or C++, you used to create an object, you used to free the object. But what if you didn't free the object? You had objects hanging around, so you would run into memory leakages. So to avoid such things, we have the garbage collector, which takes care of releasing objects as and when required. rather as and when they go out of scope. So let's take a look at the functionality of a garbage collector. A garbage collector is an application program which runs inside the JVM. When you start a JVM, the application, garbage collector application, also runs at that point. When you end your application, just before the JVM has to come out of its execution, the garbage collector execution is stopped and then the JVM comes out of its execution. What the garbage collector does is, it collects objects that go out of scope. How does it exactly execute this? It uses the mark and sweep methodology. In a mark and sweep methodology, what it does is, it goes across your entire heap and checks which memory addresses are being referenced. Those memory addresses which are being referenced, it will mark, and those which are not being referenced, it will leave it unmarked. Once this process is done, then it goes back and collects all those memory spaces which have been left unmarked. During this process, when your application is running, let's say for all your objects a memory has been allocated and it's been deallocated because your object is no longer being used, so your garbage collector collects objects which go out of scope, you end up getting fragmentation in the memory space. So how do you execute defragmentation on this memory space? This is also done by the garbage collector. There are two methods that are used. Either it uses the shift method or it uses the copying method. In the shift method, you have objects which have been allocated this chunk of memory. As and when objects go out of scope, the memory space is collected by the garbage collector. Then the defragmentation is run on the memory space. In case of shift methodology for defragmentation, what it does is, it checks this particular memory space is free now. It goes to the next memory space and checks whether if it has been allocated. If not, moves to the next memory space. Now this has been allocated. Now what it does is, it takes this content, shifts it to this empty space, moves it to the empty space. When it does this, there would be some object variable, let's call it as A1, which might be referring to this memory space, let's call it as 1000. There might be another object variable A2 which is also pointing to that memory space 1000. A3 which is also pointing, possible. You could have multiple object variables pointing to a single memory space, let's assume. When you make this shift, let's say this is a shift to an address space called 500. In all these memory spaces, we need to change the address to 500. So it goes and changes the address to 500 here, 500 here, and 500 here. So depending on how many object variables are referring to the same address space, to all those memory spaces, the change of address has to be implemented. Either this method can be used or in the change of memory spaces, or what it does is, the JVM could be implemented such that all these memory spaces are actually, that is all the object variables are actually referring to one indirection, okay, and this indirection, let's call it as n, and this n was the one that was referring to 1000. So let's say this n is at memory space 50, so all these three variables are referring to 50, that is here, and this n is referring to 1000 here. So when I shift this content from 1000 to 500, how many changes do I need to make? Only a single change, that is at n. So I could have a indirection for all these object variables, so the change can be change of address can be implemented at only a single space. So depending on the JVM implementation, it could either be having this indirection or without the indirection. So using the shift methodology, the JVM could be implementing defragmentation, or we said it can also be using a copy methodology. In a copy methodology, what happens is you have two chunks of memory. It takes the first chunk, two chunks of equal memory. In the first chunk, it will start allocating memory for objects. Once this chunk is full, and the garbage collector, when it executes and collects objects or memory spaces, then what happens is it moves the content from the top chunk to the bottom chunk. And further memory allocation will be done in the bottom chunk till it gets filled in. And again, it is possible that we have collected some memory spaces, and again it moves the content back to the top chunk of memory. So it goes on likewise. The problem with the shift methodology is that it is more time consuming, whereas here it is more memory required. So this is how a garbage collector works. Security manager, in case of application program, by default there is no restriction placed by the security manager. If you want, you can specify whatever restriction you want to place for the application, like who can access a particular class, or what are all the things that a particular class can do, or what resources can be accessed, all such things through a policy file. In case of an applet, security manager plays a very big role, because applets run on a client browser. Now, when I run a program on a client browser, the client would not want some program, external program, to access his private data, his private drive or the private network drive. Okay, so applet security manager plays a role in this. The security manager for an applet says, the sandbox, it says an applet cannot access the local drive nor the local network drive. This is the restriction placed by the security manager for a JVM for an applet, in a JVM for an applet. For application, since it's a standalone program in your own machine, there is no restriction placed by the security manager. Then the execution engine. Execution engine is the one which is actually responsible for converting your bytecode to the machine code. Now, execution engine started as an interpreter in 1.1 JDK and 1.0, where every line it interpreted to a machine code executed. This was very slow. At that point, Java was slower for about 10 to 13 times than C++. Then later in 1.2, the execution engine was modified to a JIT, just-in-time compilation. So what happened with the JIT is they provided with the cache memory. So whatever code that was compiled, it was interpreted, it was placed into the cache. Because remember, in the 1.1, it was just an interpreter. So if imagine I had a while loop for 100 times. The same set of instructions, 100 times I am interpreting and executing, right? But with cache being made available in 1.2 JIT, once I interpret the code, I put it into a cache. So next time I need to execute the same code, okay, it just needs to take it from the cache and execute the code. I don't have to reinterpret it. Whereas, in case of 1.3, the execution engine has been converted to a hotspot JVM. Again, why? Because our cache also is limited, right? So here with the hotspot JVM, using certain algorithm, it finds out what is the critical path in my code. Only such code would be compiled and placed into the cache. The rest of the code would be interpreted on its way of execution, and it executes the program. So this is how the execution engine has been enhanced to speed the Java execution, program execution. So as you can see, there's a lot of process involved in executing your Java program within the JVM itself, which is a cause for Java being slow, one of the reasons for it being slow. The JVM depends on your OS. So when you actually download a JDK kit, it will ask you for which OS you want to download the JDK for. So if your code has to be independent, there has to be some layer which is dependent on the OS, and that is the JVM. And these are the components of the JVM. Moving on further, let's look at the Java runtime memory area. In the Java runtime memory area, we have what is known as a method area, we have the heap. So we have the method area, the heap area, we have the Java stack, and the native stack. For each thread, there is a Java stack and the native stack. Native stack is used when you invoke native methods, methods written in other languages. All Java methods execute in the Java stack. So even your main, when you don't write a multi-threaded program, it's still threaded. It's nothing but a system thread. So for every thread, there is one Java stack and one native stack. So within that thread, of course, you will invoke a method. For every method that you call, it creates what is known as a Java stack frame. And in the native stack, for every method call, there will be a stack created which is called as a native stack frame. So let's say thread 1 calls a method for which we get a stack frame, and from that method you call another method, so for that method again you get a stack frame. And this method again calls another Java method, so you get a stack frame again. So let's say thread 2 calls a method, starts with a method that has a stack frame in its own stack, and that method calls another Java method, so you get a stack frame there. Let's assume this method calls a native method, so you get a native stack frame here. And maybe this native method calls another native method, that is another, let's assume it's a C method, so you get a stack frame here that calls another C function which gets a stack frame here. This C function might be calling some Java method in return, which is possible. So for that you get a stack frame back here again. So what is exactly a stack frame consists of? Stack frame consists of any local variables which you might define in a method, any arguments that you are passing to a method. When you invoke one method from within another, let's say once this method is done with, this stack is released. Once it is released, you need to come back to the caller method. I need to hold a pointer saying what is the next instruction I need to execute here. So the pointer to the next instruction to be executed is also held in that stack frame. So stack frame consists of local variables, arguments, the next instruction to be executed once I return back from the call, and also the status of the return type. All this is stored into a stack frame. So for example, let's say you're creating an instance of class A called A1 inside a function or a method. For A1, the memory allocation we mentioned, remember, is on the stack. So this is where A1 gets its memory space. And when you say new A, the memory is allocated on the heap. And A1 would be pointing to this memory space on the heap. Similarly, you might create A2. For A2 also, you are allocating certain amount of memory for I and CH, for example, which would be pointing here. Regardless of how many objects I am creating, and regardless of whichever object I am using to invoke the method, it's the same method which gets executed. So how many copies of method should be loaded in memory? Only one copy, regardless of the number of objects. So methods are loaded into what is known as the method area. In the method area, you will have something called as a method table, which basically says, so this is the method I have, and the method would be loaded in some space, memory space in method area. It points to that memory space. It holds an address of that memory space. Every object that you create for that particular class, if I say a1.get or a2.get, it ends up calling this and executing the same get method. How is that possible? Every object has a pointer to the method table in the heap for that object, and this method table would be referring to, the reference in the object would be referring to this method table. So whether I call a1.get or a2.get, it goes to the same method table, finds where the get function is, finds the address of the get function, and executes it. All static variables get their memory space also in the method table, which is a global area. Now we said a garbage collector works on the heap memory, that is, collects objects which go out of scope. For example, when can it go out of scope? Once I am done executing this function, the stack frame no longer exists. So when the stack frame does not exist, it loses that variable A2. Now variable A2 is no longer there, so there is nobody pointing to this particular memory address now. So this memory space is no longer being accessed by any object variable. So when the garbage collector executes, it collects this object. Now when does it execute the garbage collector? Garbage collector executes generally when we reach 80+% of the memory space. So when it executes, it collects objects which have gone out of scope. So question would be, can I invoke a garbage collector explicitly then? You can invoke, but there is no guarantee it will execute immediately right after you invoke it. We will talk about the invocation of the garbage collector later. So this is how your Java runtime memory area looks like. So now that we have covered the details about the JVM and the different modifiers and data types, and what are the features that Java provides us with, and the OOPS concepts. Let's now move on to looking at what is the structure of a Java file and how to write a simple hello world program in Java and to execute it. Now the structure of the Java file goes like this. You have a package statement. If at all you have a package statement, it should be the very first statement in the Java file. So package followed by the package name. This is an optional statement. Now you're going to use classes coming from different packages. So in order to refer to the classes coming from a package, you need to give the path of the package where the class is residing. To specify that, you use the import statement. Import package name dot the class name, or Instead of a class name, you can also say star, specify star here. This again is an optional statement, followed by the class or interface keyword, followed by the name of the class or the interface. Open the body of the class or the interface, define the contents, close the bracket. So this structure would be stored into a .java file. Now Sun follows certain nomenclature for the package names and the class names, and as well as methods and variables. Now how do we follow this? What is it that we need to follow? The package names are specified all in lowercase. So if you are talking about giving a package name, let's say as test package, as a name of a package, so it should be all in lowercase. Class names or interface names must begin with the uppercase, and every word first letter in the name should be uppercase as well. So for example, if I say test class is the name of a class, T of test and C of class in the name test class should be capital. Method names. Method names must begin with the lowercase, and every word after that, the first letter of every word should be uppercase. Remember, we are beginning with lowercase. So test method is the name of the method. T of test is lowercase, but M of method is uppercase. Then variable names also follow the same rules. So test variable is written likewise. Now any class constants. Now what do I mean by class constants? Constant is a final. When I say class constant, it has to be a class member, so it has to be a static member. So static final variables will always be in uppercase. Completely. Static final variables must be completely in uppercase. Generally that it is followed when you pass arguments to a method, the variable name starts with a A standing for argument. That's again a coding standard used. So now let's move on to writing a hello world program. So let's say class hello world. As this is a standalone program that we are writing, we need to have a main function. And the main function is written as public static void main of string array. To display hello world, specify system.out.println of the message to be displayed. Now let's look at what exactly we have written out here. The main function is the entry point for an application. So the return type of the main is void. If at all you are passing any command line arguments, for that command line arguments, they are all stored in the string array out here. The variable can be anything here, but it should be a string array parameter. The main function would be called by the JVM, because when I execute this program, we specify Java followed by the class name. that is hello world, which consists of the main function. So when I say Java hello world, an instance of the JVM is created and hello world class is loaded into the JVM. The JVM is going to invoke the main function by passing any arguments that you might have given as a parameter to the main function as a string array type. Now if you have not passed any argument, then the length of this array would be 0. To find out whether you have passed any arguments, or rather how many arguments you might have passed, you have a length property for the array which tells you how many elements are there in an array. So in this case, if you have not passed any argument, then the length would be 0. The main function, as it is being called by the JVM, it has to be defined as public. The JVM is going to invoke a main function which is inside a class. In Java, everything has to be defined inside a class, right? So anything that you want to access inside a class should be either be accessed using an instance variable of the class or by using the name of the class. Now if I did not have this static keyword for a main function, it would become an instance member. So if it is an instance member, I need an object of this class. Using that object, I would have to call the main function. Now the JVM is calling the main function. JVM is not creating an instance of your class. So without having an instance of a class, how do I access a method or a member? By making it static. That's the reason for the static modifier here. So that's the reason for this signature of the main function. This should be the signature of the main function for the JVM to access. Of course, if you want to have any other main function, you could write other signatures of the main function. But that becomes your user-defined method, not the method where I need to start my application program with. This is the only main function signature that the JVM understands. Coming over to the next line in the main function. You want to display hello world onto the monitor. That's the standard output device. In order to represent the standard output device, we have the out here, which is representing the standard output device. So to display anything on the standard output device, you say system.out.println. Now let's look at what each one of these are. Now println, you're having a bracket here. And another thing is println p is starting with a lowercase. If you go according to the nomenclature, naming standards, anything that starts with a lowercase either has to be a method or it has to be a variable. Since there is a bracket here right after the name, this of course has to be a method. So println is a method. This println method is being accessed using out. So what is out here? Is it a class? Is it a variable? Is it a method? Now since there is no bracket for here, it's not a method. And this out is starting with lowercase. So it cannot be a class or an interface name. So it has to be a variable itself. This is a variable of class printStream. So this is an object variable of class printStream, and inside this class printStream, println method has been defined. So there are overloaded println methods in the printStream class. One of the method is that which takes the string parameter. Now what is this system here before out then? System has to be a class or an interface because it is starting with the uppercase. In this case, system is a class where out has been defined in the system class. If I'm accessing something using the class name, it has to be a static member of a class. So out therefore is a static or a class member of class system. So therefore system.out. So this is a signature to print on the screen. How do I give a name for this particular program? Let's call it as first.java. Now you might think, shouldn't the name of the file be the same name as the class name? Well, it has to be the same name if the class is defined as public. But right now, since we have not specified any access specifier, therefore this class is a default scope or a package scope. In such a case, I can give any name that I want for the Java file. Remember again, if the class is a public class, then the file name has to be the same name as the public class file name. In a Java file, we can define any number of classes in a single Java file. Out of the n number of classes that you are defining in a Java file, only one can be defined public, because the name of the file has to be a public class file name. If you give more than one class as public in a single .java file, what is the name that you would specify then? So there can only be single public class defined in one .java file. If you need to have all the classes as public classes, then you must define each of the classes in a separate file so that you can specify the appropriate name for the Java file. So when I compile this Java file, what do I get? So in order to compile this Java file, we need to use the javac command. So we say javac followed by the Java file name. So here in this case we say javac followed by first.java. So when we compile this code, we get a .class file. The .class file name is the same name as the class name. So it is hello world.class is what we get. Now once you have a class file, then you execute it. In order to execute the program, you use the java command followed by the class name. Now when you write the class name, you just say hello world and enter. This executes the class file to display hello world on the monitor, standard output device that is. Now in case you are getting an error out here saying no class def found error, then it means to say that the class path has not been specified. Now in order for the JVM to be able to load a class that you are specifying against the Java command, it needs to know where the class file is available, and this can be specified with the class path variable. Please do not get confused between your class path and the path variable. Path variable is used to specify where the executable files are, like the java.exe, the javac.exe. If you need to specify where it is available because it's an external command file, you will specify that in your path command. In order to say where the .class file is available, you use the class path variable. So if the class path is not already set, you need to set the class path by at your command prompt or go to your environmental variable in My Computer Properties Advanced option, create a class path as a variable name and specify the path where, that is the directory where your class file is residing. So if you're going to set it at your command prompt, you say set class path is equal to wherever your file is available. Let's assume that we are under C drive work directory. Under this we have hello world dot class file. So in order to say that hello world is under work directory, you specify C:/ work dir. In case you have had some other class path set and you would like to add to that class path a new path, then you must use ;% class path %, so that whatever previous class path had been set, along with that you have attached the new path, and then execute your Java and the file name. Now it would be able to execute your class. Now let's assume that your javac or Java command itself gave you an error. In that case, your path has not been set to where the javac or the Java command is .exe file is available. So in that case, you need to set your path to your JDK directory wherever it has been loaded. Let's assume that under C drive you have the Java directory. Under that you might have your JDK. You have your bin directory under JDK. So specify the path to that bin directory. %path %, so that you retain whatever path that is already available. Then you execute your javac and your Java command. Now let's move on to writing some more classes into the same .java file. Let's assume I have class A and class B in the same Java file. When you compile this code, now javac first.java, you get 3 different class files, each class file for one class. So you get hello world.class, a.class and b.class. Now which one of these class files will you use to execute the program? You need to use the class which consists of the main function, public static void main string array. So again, here in this case it's the hello world class which consists of that. So you'll say Java hello world. So your doubt might be, what if I write another public static void main of string array in class A as well? Now it's your choice in that case which class you want to use to execute the program, but generally you wouldn't do it, but this might be your question. So in that case, you could either run your application through by saying Java A, or you can say Java hello world, depends on from which point you want to execute. Now the whole program, we have seen that we are using the system class and the string class. Now where are these classes, and how come we did not say we did not give any import statement to those classes? Now the system class and the string class both are defined in a package called java.lang. Now this java.lang.star is an implicit import to all the Java files. So that's why we did not explicitly write the import statement. Now let's take a look at some of the classes in this lang package. Starting with the class called object. Object is the root class for all the classes. Any class that you talk about, let it be the predefined Java API classes or let it be the classes that you are defining, the parentmost class is the object class. We wrote a class hello world. We did not extend that class from any other class explicitly. So what happens when I compile is that the compiler inserts the extend statement onto the class, extending it from the object class. So finally, at any point, object class is the rootmost class. Now what does this class have to provide us with? It provides us with a equals method, for example, which returns a boolean and takes object as a parameter. This method compares two objects and returns whether they are equal. Then we have the clone method, which returns an object. Clone is a method which is used to make a bit by bit copy of an object. We will be discussing about the clone method after covering exception handling and at the end of interfaces. We have the hash code method. Hash code is a method which returns a hash value for an object. We have the wait of milliseconds. Notify all. These methods we will discuss during multithreading. We also have the get class method. The get class method returns a class object. Now class here, uppercase C class, is a class also. This also belongs to a lang package. Get class is used to make a reflection on a class. Now what do I mean by a reflection? What do you see when you take a reflection of yourself? You see about yourself, right? So similarly, you want to find out what is there in the class that has been defined. Then you need to get the class object for the class for which you want to find out the definition of. So get class is a method which returns a class object. Class is used to make a reflection on a class. For example, let's say I define class A and I would like to find out what are the contents of class A, like what are the variables, what are the methods, and what is the name of a class, what is the scope of the class, what is the parent class for this class, etc., etc., etc. So I can find out by making a reflection on a class. So I create an instance of class A. On that instance, I call a getClass method. Now getClass is a public method of class object. When you have written class A is derived from class object because it's a rootmost class. So therefore, class A has inherited all these methods. And getClass is being a public method can be accessed through an instance of your class. So you create an instance of class A, invoke the getClass method, it returns a class object for class A. Now where does it return a class object for class A from? What happens in the JVM is whenever classes are loaded into the JVM creates a object of class for every class loaded into the JVM and puts it into the hash table which the JVM maintains. A hash table is a key value pair. So remember, for every class loaded into the JVM, a class object, an instance of class is created. So let's take in case of your Hello World program. So Hello World is loaded into the JVM. For Hello World, a class object, let's say HW, class is a class object for it. Your Hello World class is making use of string class. So string class has to be loaded. So for the string class, a class object is created. System class is also loaded because you are saying system.out.println, for which a class object is created. Similarly, any other class that is loaded, like print stream again, for which a class object has been created. No matter how many times you use the same class, only once that particular class would be loaded, and for which the class object would have been created and kept in the hash table. Now you create a class A, you create an instance of class A. Using that instance, you call the getClass method. The getClass method, what it does is, it goes to the JVM, finds for class A, this is the key, class names are the key, the value is the class objects. So it finds in the key the class name called A. Once it finds class A, it gets the object, class object for class A from this hash table and returns that class object. So once you get the class object, then you can use the methods of the class to do a reflection on your class or to find out the details of your class. Now let's look at what are some of the methods that class gives us with. We have, for example, getName method, which returns a string. It tells me the name of the class. We have getSuperClass, which returns a class object for the parent class of the class on which I am doing a reflection. getInterfaces returns a class array. You can implement more than one interface on a class. So therefore, getInterfaces returns a class array, one class object for each of the interface implemented. Then we have getMethods, constructors, fields. We also have getDeclared, methods, getDeclared constructors, and get declared fields. Get methods and get declared methods, both of them return an array of method. Get constructors and get declared constructors return a constructor array and get fields and get declared fields return a field array. Now these particular classes are available in a package called java.lang.reflect. So we need to import this particular package to work with these classes. Now what is the difference between get methods, get constructors, get fields versus get declared methods, constructors and fields? In case of the get method, constructor, fields, it will return you all the methods or all the constructors and all the variables which are publicly defined, starting from whatever I have inherited from the object class till the class where I am doing a reflection. Only the public members, starting from object class till the class on which I am doing a reflection. Whereas get declared methods, constructors, fields return you all access specified members, but only those members which have been declared or defined in that particular class for which you are making a reflection, not what is inherited. Remember here, the get declared methods, constructor, fields returns all scoped members, but those only which have been defined in the current class on which you are doing a reflection. Whereas the first set of getter methods are returning you only public members, starting from whatever you have inherited, coming from the object class all the way down to the class on which you are making a reflection. Now since each class can have more than one method, more than one constructor and more than one field, that is a variable, for each method, constructor and variable there is an object created, therefore this is an array here. Now once you have your method, constructor or the field object, you can find out from these classes, for example in case of a method class, you can find out the name of the method, where the method has been declared by saying get declared class, what is the return type of the method, what is the scope. You can also invoke a method. Imagine a case where get declared methods is returning your private method as well, and via reflection you are trying to invoke a method. You get a runtime error saying illegal access exception. So although you have an access using a method object, if you were to try to invoke it, you still get an error. So you cannot access the appropriate scope members outside its area, outside its scope. You also have here a very important method called new instance, which returns an object. Using new instance, you can create an instance of your class. So you have two ways of creating an instance of your class, either by saying new and the class name, or by calling new instance. When you call new instance, it always calls for the default constructor. So in such a case, you must always have a default constructor for a class. Otherwise you get an error. Now why would I use a new instance to create an instance of a class? For example, you might have seen your builder tools where objects can be dragged and dropped into a design area. Now the design tool will have to make a reflection on your class and create an instance of that particular object. How does it create an instance? By calling for new instance method. So this is about reflection. Now let's take a look at the system class. The system class has all static members, class members. We have seen one of them, that is out variable, which is a variable of class print stream, which represents the standard output device. Similarly, a standard error device is represented as an instance of variable ERR, which is of type print stream. We also have input stream object called in the system class, which represents the standard input device. Apart from that, there are several other methods out here. For example, array copy, which takes an object array, that is the source, the starting position in the array where I need to start copying from, and the ending position where I should stop the copy, followed by the destination object array into which I want to copy the array contents, and its starting position where to copy into. We also have exit method, which takes an int value as parameter, and this int value says how I'm exiting from the program execution, whether I'm exiting successfully or unsuccessfully. So using system.exit, I can exit out of my program execution. We have load library, of string, which takes the library name. This is used to load the DLL file in which you might have defined your native methods. You have get and set security manager, get security manager returns your security manager object telling you whether any security manager has been set for your application. Similarly, you want to derive with your own security manager class, you can write that specifying what restrictions you want to place on your application, and load that security manager by calling set security manager in your application, passing the object as parameter. You also have GC, stands for garbage collector. Remember, while speaking about garbage collection, we said we can explicitly invoke the garbage collector function, but we also mentioned that does not guarantee you the garbage collector will execute at that point. So how do I call for a garbage collector? You call for it using the GC function from the system class. When you invoke this function, at the time of invoking this function, there is no guarantee that this method would be called. It will be called definitely sooner than it would have actually executed the application would have actually executed the garbage collector. Okay, but it does not guarantee the instance you are calling this garbage collector that it would invoke it. We also have getProperty method, which takes a string as parameter. That's a name of the property, which returns the value of a property. Now what is this property? There are a set of environmental properties which are set for your JVM, for your application rather. For example, what is the name of the JVM? What is the version of the JVM? What is the class path specified, etc. are specified as properties in your application. So if you know the name of the property, you can specify that for your getProperty method. It will return you the name of the property. You want to find a list of properties which are loaded. You can find out from calling a method called getProperties, which returns a properties object. Properties is a class in java.util package. So you need to import java.util out here. Again, the properties class has list of methods using which you can set the value of, you can set a new property to your environment. You can get the value of a property which is already existing. You can call the list method, passing the printStream object as a parameter, which will return you a list of all the properties loaded in the environment with the variable value pair as a list. You can also specify properties for your applications to be used and into a file, and this file you can load as properties into your environment by calling a load method on the properties object by passing a stream object for the file.